Let me make some room here. So if you go to the class website, you're going to find, so under the calendar here, there is a lab 3 here, and it's about using several classes to draw, here maybe I should say to animate. And so we did a smiling face, and we're going to see how we can add animation to it. So let me bring all of these back to an Eclipse project. And so if I refresh this, you should see the files. So let me delete what we don't need. So smiling face is what we did last time. And so just to see what it looks like as a reminder, I can just run it quickly here. I'm going to delete this, but you see I could put a main method here, not here, here. And I could say new smiling face in some, so let's create, of course, a graphics window. So again, this is just something very quick so that we see what we have. So 100, 200, 0.5, and so in our window. And I'm going to give a better size to the window because right now it's not going to be big enough. So let's have it 800 by 600. And let's have another smiling face here below. And let's say it's at 400, 300 with a 1.5 scale. So if I run this, so it says there are errors because the other files that I brought back are incomplete, but let's say proceed. I'm just executing this one. So you see we get that. So we get the two smiling faces with different scale. So what we would like to do today is have a window that displays smiling faces, but we're going to have animation. That is, we want to be able to see them move. So the engine for the animation is done, and we're going to see how to do it. Let me open the chat here. I missed. Okay, sorry. So you can hear me? Okay, good. Now, thank you very much. Okay, so let's see how we proceed. So I'm going to delete this. This was just to run it quickly here. But the main method is not this one that I want to execute. It's going to be one in funny pictures. So let's look at how it goes here. But this one is incomplete. There is an error. There are errors because not everything is in there. Notice here that for the import statement, if you don't want to go through all of the steps of saying, oh, I want a G window, I want a rectangle, and so on, you can use a star here. So it's a shortcut to say any class name that you see below, if you don't recognize it, well, look for it inside of that package. It's a shortcut, but maybe not something that is recommended. Why is that? It's because when, as a reader, we look at this, we don't know which classes of the package are used by the program. So it's better to have a list that gives you the full classes that are used, and you can easily change this in Eclipse. So if you do Control Shift O, you get a reorganization of the imports. So I'm going to do it here. So if I do Control, so this is the key I'm going to type here. So if I type Control and then Shift, and then O. So O is for organize imports. So if you do this in Eclipse, and I'm sure there are similar keys for other platforms, you get your import statement written for each class. So let's see it here. So let me clear this here. And I'm going to do it now, Control Shift O. I need to select the class. So here it is. So you see now it gave me all of the classes that we are using in the UW CSC.graphics package. So some of them we recognize GWindow to create a graphics window, rectangle for the background here. So we put a rectangle over the entire window. We have other classes here, a GWindow event. On a GWindow event adapter, it appears here with that writing. I'm not going to explain it. We're going to encounter that keyword at the end of this quarter when we study inheritance. So at this point, just take this as is. The goal of our second homework and the goal of this activity to prepare us for the second homework has nothing to do with this. But of course, it has to be there if we want to have an engine for the animation. So what is going on in this class? Well, as usual, everything is going to start with the main method. So the main method is below here. And we just say create an instance of the class funny picture. It is the class we're in right now. And so what is going on? Well, when we call the constructor, we recognize some steps here. So we create a graphics window. It's going to be 300 pixels by 300 pixels. We have that instruction here, and as the command says, it's to make sure that when you close the window by clicking the X of the window, like this X here for Eclipse, the full application terminates. So any program that was running on the side, it's going to be closed automatically. What would be these programs running on the side? Well, it's for the animation. Then, we put some elements in the window. So first we have a background here. It works, but it's a good style to have it all capitalized because it is a constant. So we create a background, a full rectangle that covers the entire window. That's why here we have get window width and get window height for the size of the rectangle. And then we create two faces at some location with some scale. And we create two trees, but the pine tree class is not complete, so the trees will not appear. If you want to see how to draw a tree, you can go to the solution, which is here on the class website. And then here we start the animation. Again, the code for the animation is going to be given to you as part of your second homework assignment. You won't have to change anything to it. So this is just to start the animation. How does the animation work in a nutshell? The graphics window comes with a timer. So what you can do is ask the timer to tick at regular time intervals. This is what is going on here. Second project, so right now you're working on the ocean scene. So in the second part of your, so in the next programming project, there will be a continuation of your ocean scene program, and you're going to add the animation to it. That's what I mean by that. So here, the timer is going to tick at regular time interval, and it's going to be every 100 milliseconds. So every 0.1 second, it's going to tick. So what does it mean that it's going to tick? Again, it's done automatically for us, but it means that this method here below, timer expired, is going to be run every 0.1 second. So this is how the animation gets going. If somehow via this method, you change the location of some of the elements in the window, well, then it's going to give some motion over all of the elements through the window. So what is going on in there? So we stop painting here the window. Why is that? It's because sometimes automatically the window will be refreshed by the operating system, but we don't want this to happen while we are doing the animation, well, one step of the animation. Why is that? It's because we're going to redraw some of the elements, and we don't want the window to repaint itself when we're halfway redrawing the elements. We want to do it only when it's all done. So that's why we say redo the painting of the window after we are done with all of this. So what is going on in there? So we have an animation counter. It's so that the animation doesn't go on forever. So it's a variable that is here. Automatically, it's going to be set to 0. We know that instance fields that are left alone, they get automatically a value. And for a number, it's going to be 0. So every time we go through timer expired, you see here, we're going to add 1 to animation counter. Plus plus means animation counter is equal to animation counter plus 1. It's a shortcut for that statement. And what do we do in there? Well, we say if the value in animation counter is less than or equal to 100, we're going to do this for the elements. So phase 1, phase 2 on one of the trees. And if not, we're going to do the following here. And if the animation counter gets larger than 200, then we stop the animation. So the key part for us is to understand these lines of code here. And this is just given as a design. You're going to see that in your homework, it's going to be slightly different. But here, as we can understand via the name of the method, we would like phase 1 to move by some distance. And it's going to be, so what we would like to happen is going to be the following. Of course, it's not happening yet. But if you take the graphics window, so we have a smiling face in there. When we use move by here, we would like the smiling face. Well, as it is written here, it says 1, 1. So this is our x-axis and this is our y-axis. So we would like the smiling face to move by 1 pixel in the x direction. That's what this one is for. And again, there's no way we can guess it. And this is not a method from the UW library, just something that is given here as a suggestion. And we would like also the smiling face to move 1 pixel down here. So 1 pixel is not a lot, but of course, overall, it's going to move at 45 degrees down like this. And if you do this over and over again, well, it's going to move at 45 degrees down on to the right. There is a flip color also that we can do for the tree class, but the trees are not drawn. So again, this one we can ignore. It's done in the solution here. So the key part right now is for us to write code for these methods. And of course, for the tree, we're going to do it so that the error goes away, but we won't be writing code inside of the method. So let me ask you here. The Eclipse here is telling me, well, there is no move by method at this point here. So I need to create a move by method. So where should I write it, first of all? And then when I write it, what should be the signature of the method? What should be the first line of the method? Any suggestion for that one? So again, the question is the following. Where to write move by, and what is the signature of move by? So first of all, which class should contain move by? So the original class, so what do you mean Paris by this? Because here we have three classes available: funny picture, pine tree, smiling face. So should move by be defined in funny picture, pine tree, or smiling face? Smiling face, indeed. So how do we know that it has to be in smiling face? Well, it's because if we look at the syntax here, we say face one dot move by. So move by is an action of face one. And what is face one? Well, here, if I bring my cursor on top of face one here, face one is a variable of type smiling face. So move by is a behavior of smiling face. Therefore, it must be in smiling face. So here we got it. It has to be in a smiling face, since it is a behavior for face one, which has a type smiling face. Now, what should be the signature of it? So by signature, it's what I mean is it public, and then the return type, name of the method, list of the arguments. So what should it look like? And of course, I'm going to have to write this not here. Here it is a command, so it's okay. But I'm going to have to write this inside of smiling face. So public or private to begin with?
Public,
On why public? It is indeed public.
because we want to use it on a class that is not smiling face.
Very good. So we want to use it outside of smiling face. So we want to have access to it outside. So public is a keyword for that. What about the return type? So what should be now? What follows is you see the return type. I'm going to remove this, of course, but what should be the return type? Remember what we call the return type? Indeed, it's going to be void. So how can we know that it is void here? Well, if it had the return type, for instance, let's say it was returning a double for whatever reason, then you don't have to, but you could write something like this. If it was returning a double, you could say double x is equal to this dot face one move by. It was giving back a double. But we see, of course, that in the code that is suggested to us in funny picture, these lines of code are just calling move by, but they don't use a return value. Doesn't mean that there cannot be a return value. We don't necessarily have to use a return value, but why returning a value if we're not going to use it? So if we don't need any return value, we're going to say that the method is of type void. So then it's going to be the name of the method, which is move by. And then we have the list of parameters here. So what do you think is a list of parameters? So you just need to look at what is between parentheses here. And then you ask yourself, how many do we have? What are their types? So indeed, we have two of them. So we could call them X and Y, sure. What would be the types? Because remember that when you write the signature of a method, you must give the type of the parameters, not just their names. So int, indeed, we see that we have here int. So now it doesn't mean that it's strictly speaking, it doesn't have to be an int. It could be, for instance, a double, because you can send the value of an int to a double, because automatically Java is going to turn the int into a double. But since we're only sending ints, might as well have parameters on the other side that are taking it as an int. So the list of the parameters is going to be two ints. And of course, we need to give them names. So here the names, well, it's up to us. We want something which is possibly meaningful. And of course, here nothing, well, now it's just the name of the method, which is suggesting what it is doing. So here it's a method that is going to move by some value along X and along Y. And again, here it's more a guess of the suggestion. It's not explicitly written for us, but so we can guess that the first parameter would be the displacement along X, on the second one, the displacement along Y. So we could call this X on Y, but maybe a better name would be a displacement along X and a displacement along Y. So we could call this a dx and a dy instead. So this would be the displacements along X and Y. So we can write that in a smiling face. So we can do it here. So this, well, draw the face, and now here it would be, so move the face by the given displacement. And the two parameters would be, so dx, the displacement along the x-axis, and we have then dy, the displacement along the y-axis. And then we can write just public void move by, and then int dx, int dy. So we have written that. So as soon as I write this, you see these errors are going away. So now move by is known. Of course, move by doesn't do anything, it's empty. But for the compiler, now there is such a method. We need to do the same with flip color. So let me ask you the same question. Where to write flip color, and what is the signature? So what do you say? Which class should contain flip color? Again, look at the list of the classes that we have available. Pine tree, indeed. So why is that? Well, it's because tree1 is, we can see it here, it's a variable of type pine tree. So when we say tree1 dot, what we can write after the dot is a feature that is given in the pine tree class. And here that feature is a behavior, it's a method. So it means that we want a method flip color in pine tree. So it would be in pine tree, since tree1 has a type equal to pine tree. What would be the signature? So again, signature means something like that. So is it public, private, return type, any parameters? So indeed, so public because we want to be able to use it outside of the class. Void because here, and again, this is not a strict requirement. It could return a something, a value, but if we don't use it, why? But here we don't have anything that says x equal, for instance. So it looks like we don't use any return value, so void is good. Then it is the name of the method, so flip color. And then we see that it doesn't take any, here it doesn't send any argument, so there's no need to have a parameter on arrival. So that would be the signature of the method here. So we can go to a Pine Tree. You're going to see that Pine Tree is basically empty here. But the solution is available on the class website. But this would, so flips the color of the tree. Well, it's more the foliage of the tree. And so public void flip color. So as soon as I do this, you see that all of the errors here are gone. So if I save a funny picture, well, if I save everything, I won't get any errors in my project anymore. So I can run the program, nothing will happen because the methods are empty, but we can see that they're called. So for instance, here, if I do move by, so it's called here. So we're going to see that that is indeed the case. And if I do the same for Pine Tree here, for flip color in Pine Tree, so flip color is called. Now, if I run the program, this method should be called over and over again, well, for each element 200 times, because that's what we do here. So we can see that indeed that's going to be the case. So let me run the program here. And so you see that, that's what I want here. But you see that in the console here, it's called over and over again. But the picture doesn't move because the methods are empty. So this is going to be done as long as the animation counter is less than 200. Actually, I could have also printed the value of animation counter. We would have seen it here. So here, if I were to print it, so that you can see indeed that this is what is happening. So let me run it again. So you see that we have the animation counter that is going on, and it's going to go like this until 200. So we can stop it. And now think about what we're going to write in terms of code. So let me delete this on that, because when we do the animation, we don't want all of this being printed. And we're going to work on this one this morning here. So what do we do here? That's the key point now. So the job of the method is, okay, we have to move the smiling face by a certain distance. And what we have done is we have a method here that can draw the face at some location xy. So how would you draw it at some other location? So this is what we have here. Clear this. So we have our smiling face. So at this point in the smiling face class, we have the tools to say, okay, let's draw a smiling face at some location xy, that is the center of the face. So now the method that we want to write, so it's receiving a dx and a dy. Let's say dx is this, and dy is something like that. So what we want it to do is now it should draw the smiling face at that location. So we would like it to take the smiling face and draw it here. Of course, it's going to be moved only by 1 pixel the way we had it, but move by should work with any dx and any dy. So how do you think we can take the face and draw it here with the tools that we have here? So what could we do to move the location of the face and then say, draw it again at that location? And again, this method here draws the face in the graphics window at xy. So we have, if we call this method, we know that we can draw the smiling face. But this is telling us we want to change the location by dx and dy. So what could be the simple steps that would say, let's change the location and then let's draw the face again.
I'm sorry, do you mind repeating the question?
So the question would be, right now we have a method, draw face, that can draw the face at location xy. And xy were given as a, well, they were initialized as instance fields here. But if you call this method here and you have a value of xy, that method is going to say, okay, I'm going to draw the face at xy. Now move by, what do we want it to do? We want move by to, well, change the location by dx and dy. And then we'd like the face to be drawn at that new location. So how could we do that? Indeed, thank you, Ethan. Here, that's we can change the values of x and y, and then we can say, well, draw again at that location. So let's do that and see what it does. So we can update the values of x and y. So we could say x. We don't have to say this dot x here, because when you say x, since there is no local variable by the name x, it's going to be automatically the instance field. So you could say x is equal to x plus dx. Now there is a shortcut for that. Instead of writing that, you can write the following: x plus equal dx. This is the same as writing that. Here it's not a big advantage, but if you have a long name here, you see you write it only once here. Here you have to write it twice. And so you can do the same for y. So now x and y are going to be updated, but this is not going to move the face in the window. What we are doing here is just changing some location that are stored in memory in the variable x and y. But if we want to draw the face again, well, we can call that method again. So we could say here, redraw the face at the new, well, at the updated location. So how do I call this method? What line should I type? What code should I type on 52 to say execute the method draw face? Indeed, you would say this dot draw face, or you can just say also draw face, because when you don't explicitly give the name of the object, automatically the computer will understand that you mean this dot. So you could say this dot draw face, but this is also a draw face just like that also works. Now, when you write the following here, maybe we emphasize, and maybe that's a good idea when we are learning the language, we emphasize that any method, any instance method is always executed with an object. Even if that object doesn't appear explicitly when you write it this way, it is there implicitly as this dot. So let's see what this does. And you're going to see that it's going to move the faces, but there will be a problem. So let's see what it does here. So if I do the animation, so you see it's moving, but you can see that there is a problem. It leaves a trace behind. It's because the face that was there, well, is still there. So that's not exactly what we want. It's almost working, but not fully, because, well, we have to get rid of the original face. So here there is a step to do, which is, well, we need to erase the face that was at the original location, and then we can draw the new face at the new location. So let's see how we can do that here. So there is a step here that is missing, which is erase the current drawing of the face. So how do we do that? Well, we need to have a way to remove shapes from the window. So we cannot guess how to do it without looking at the library. We need to see if there are methods in the library that allow us to do it. So let's see what's available. So let me go to the documentation here of the library. So let's see what a G window can do here. So if we go to the methods, if we scroll down, we see that we have erase here. So erase is gonna clear the entire window. Or what we can do also is, it's below here. If you don't want to clear the entire window, but you want to remove only a shape, but that shape has to be something understood by the graphics library. So you see, you can remove a rectangle, you can remove a line, well, anything that is listed here on the side. But of course, there is no smiling face class in there. So we're not going to be able to remove a full smiling face just in one line. But you see, we have remove and we have erase. Removes returns a Boolean, maybe because the shape might not be in the window and then it could say false, but we don't have to use that return value here. So maybe we want to try erase first to see what it does. But you can imagine, of course, that it's not going to be great. See, as I run it right now, for instance, I have the background here. But if I use erase, the background is going to be gone. But let's see what this would do. So I could say window, because we have access to the window here. It's an instance field here. So I could say window.erase. But let's see what this does. So indeed, what is happening, it's only the last smiling face that's going to stay in the window. All of the rest is going to be removed. So it does do what we want to do, but only for one object, not all of them. So this is not valid. If you have more than one full object in the window, like see a background, if you had trees and so on, they would be all gone because of that. So it's not what we want. So here, what we would like is how, well, we want to remove the shapes making up the face one by one. So how do we do this? Well, we have to go through the list of all of the shapes and say window.remove. So what are the shapes making up the smiling face? So here we have to look into the details of the drawing. So it's down there, it's starting in draw face. So the first shape that we have here is the head here. So we need to remove the head here. So we could be tempted to write something like this, window.remove, and then head. But it doesn't work. Can you tell me why I cannot write that line of code here? Even though I have a head variable here, but it doesn't work here. What do you think that is? And once you understand that, maybe we can try to find a way to make it work. Because I want to remove, of course, the head. Indeed, it has to do with the scope. Very good, Yui. So what kind of variable is this? How do we call such a variable when it is declared inside of drawFace? Local, indeed. So we talked about scope in the videos here. So remember, a local, so head is a local variable. So what does it mean? It means that here head can be used between, well, if I use the line numbers that are here, between the line of declaration of the variable 65, and then the end of the scope of for the variable head. So it's going to be the end of the method, so 83. So I cannot be used, it cannot be used outside of that. But I would like to be able to use it here. So how can I make a variable available in more than one method? Have we seen some kind of variable that would be available in several methods and actually the entire class? Are there variables in our program right now that we can use everywhere. Indeed, we can create on instance fields. So if instead of having head as a local variable, we make it on instance field, then head can be used in several places, in several methods. So what we want to do now is, so this is not good. Of course, as soon as I add line, so this is not going to be valid here. So it can be used between its line of declaration. So this line here, this is what you call a declaration. On the end of the method. So what you want to, I can type. So what you want to do is to make the variable available in other methods, make it on instance field. So how do we turn it into an instance field? Well, we've seen how to do it. We have here the list of the instance fields. So you just need to declare the variable outside of any method. Now we put the instance fields up here. They don't have to be up here. I'm not going to do it that way, but you could have it here, for instance. You could say, let's have a declaration of head as an instance field, and you could write the declaration here on line 61. Not a good idea, because then it's hard to find it. It's kind of a mess to read the code, so you don't want that. But let me do it, and of course, I'm going to move that line of code here. But how would you write a declaration of a variable head as an instance field? What should I write on? I could write it here. Again, I'm going to move it just after writing it here, but here I'm going to start writing it here so that we can see how we can take this variable and make it an instance field. So what should we say? So remember, for an instance field, we have 3 parts. We have the access modifier, we have the type, and we have the name of the variable. So access modifier for an instance field. We have 2 choices, private or public. What is the recommendation for instance fields, public or private? Private indeed. Again, the rule of thumb is use private unless you have a good reason to make your instance field public. Because if you make it public, then you have no control on the values that can be assigned to the instance field. And sometimes you don't want any value in there. So here we would say private. What would be the type? You can just read it on line 69 here. Oval, indeed. So, and then the name, well, it has to be head. So you see, as soon as I do this, the error here is gone. Because now there is a variable head that is available throughout the entire class. So that line of code works here. Now, of course, I don't want to write this here. I mean, you can, but it's not a good idea. So instead, I'm going to take this line of code and I'm going to write it here. So we're going to have here, so the shapes making up the drawing of the space. And so we have this one here. So now it looks like my code may run, at least head can be removed. So I'm going to run it, but look carefully. It will not work. So you see, again, we see here that the code compiles. We don't have any red icon anywhere telling us that the code is not correctly written. So the compiler says it's okay, but it will crash. So let's see why. So let me run it first so that you can see it crash. So this is what is happening. We get this red message here. And you see the problem happened. So you have here what you can call sometimes the trace of the calls, the call trace. So it's a list of the methods that were called that led to the error. So where did it start? Well, there is a thread. So it's that little piece of code on the side running. That's what I meant at the beginning when we had the set exit on close, making sure that everything closes. So there is a little piece of code here running. It takes care of the animation. So this was coding timer expired called move by called remove. And then this is the details of the implementation in the UDAB window. So in the UDAB graphics library. So we don't have to look into that, but somehow we got a null pointer exception. So something was null. And of course, the problem certainly came from here, because this is our code. And if you want to know where it is exactly, all of these are links here. So you don't care about these links. This is going to take you to a code of the library, but of course the error is not there. It's in what we wrote. So let's click on this. So this means on line 54 in the smiling face class, there is a problem. So let me click on that. So it is what I wrote here, window.remove head. Something is null in there. Well, it cannot be the window, because the window is, we know it's been created. So head has to be null here. So why is head null? Well, it's because head is on instance field. And we know that on instance field, if we don't touch it, well, its value is going to be automatically set to null. But why is it that we don't touch it? It looks like we give a value to head here. But what is the problem here? Do we work with the instance field here? Or is there something else happening? Why is this not giving a value to the instance field? And that's an important point here. And you can see that it is not the instance field for Eclipse, because look carefully at the color coding. Head here is in blue. It is the instance field. Head here is in some brown colored font, but it's not the instance field. So why is this? Indeed, you're correct here. So what we're doing here, we're still declaring a variable that we name head here. So we still have the local variable head. So that local variable hides the instance field head. So when we do this, we give a value to the local variable, not to the instance field. But of course, if we create an instance field in our logic, we don't want to have a local variable anymore. So as you suggest in the chat here, you don't want that. So you can write, instead of head, you can write this.head, or you could also just write head. So here, look carefully, I'm gonna remove the oval type. So the declaration of the variable will be gone, meaning that when we say head now, it's gonna mean the instance field. And look at the change of color of the variable here. Eclipse is gonna tell us this is an instance field. So I'm gonna remove oval here. And you see that this has turned blue. So now it is the instance field. So now this is not going to be null anymore. And we can then remove it. So we're going to see that indeed it's going to be removed. So let's run this. So now you see that the head is removed. So we still leave behind some trace. It's not as big as before because the head is being removed, but we have the eyes, we have the nose, we have all of the rest here that is not removed yet. So what we need to do now is go through all of the shapes making up the face and turn all of the local variables that we have in all of the methods and make them instance fields. So let's go through the list here. I'm going to do the eye at the end because for the eyes, there's a little bit of a twist here. But see, for the nose, we have a triangle here. So I'm going to make the nose an instance field. So what I'm doing is I'm going to remove all of the declaration of local variables, and I'm going to create instance fields at the top by the same name. So we have the nose. We have here for the smile 2 ovals. So let me take these. So we have 3 variables here to do. It's not complete yet. We're going to have to do the eyes, but here we have the nose. It was private triangle nose. Then we had private oval, so it was the black circle on the yellow circle. So then what you can do is in here, now you can say window.remove nose. And you can say window.remove black circle. And you can say window.remove yellow circle. Now with this, we can see that only the eyes will be left behind here. If I run this again. So now it's only the eyes that are left behind because this is what I haven't done yet. Well, let's do the eyes. So for the eyes, there's a little bit of a twist here because given an eye, given when we draw eye, we call it twice. So for we're gonna have for an eye, for the face, we're gonna have two eyes. In one eye, we have two shapes here. So you see that we have the eye and we have the pupil. But actually, so when we draw the face, there will be four shapes. We're gonna have two ovals for the left eye, and we're gonna have two ovals for the right eye. So if you were to take these out, well, sometimes this is going to be for the left eye, but sometimes it's going to be for the right eye. So we cannot really just turn this into an instance field. What we need to do is create our four shapes here. So the four shapes for the eye. So it would be left pupil, left eye, right pupil, right eye. And so when we go to the drawing of the eye, sometimes this is going to be for the left eye, sometimes it is going to be for the right eye. So what we would like to do is finding some condition here, if, well, whatever, we're going to see what it is. So we would say left eye is equal to eye, left pupil is equal to the pupil. And if it's not the left eye, well, then it must be the right eye, what we just did. But how do we know that we are drawing the left or the right eye? Again, this is going to maybe help us because we have the location of the eye. So how would we know if we are drawing the left or the right eye? Any idea here? Again, you see this is the situation. So you have the smiling face. XY is here. So when we draw the left eye, well, it would be the right eye on the face, but left when we look at it, let's say. So IX would be this. So that's for the left eye. But if we are looking at the right eye, IX would be here. So how do we know if we are drawing the left or the right eye? What kind of comparison could we use with IX to know if it is the left or the right? Indeed, we can compare X with IX. So if we do that, here, if we were to say if IX is less than X, then we have the left eye. If not, it must be the right eye. So given that, now we get the right values here. And now we can say here, window.remove, and we can say left eye, window.remove, and then the left pupil, then window.remove the right eye, and window.remove the right pupil. So now given that, we get the correct animation now. See, things are moving as we want them to move. We can even organize your code better here. See, very often when you write a method, you don't want to put all of the details in the method. So what this is doing is just erasing the face. So we give all of the steps here. But instead, what we could do, we could have a method here that erases the face from the window. So it's a detail of our implementation. And what you could do is take all of this code here and move it here. And here you would just say erase face. You could say this.erase face as well. But this is very often how you want to program. you see step by step. First, you want to say what you're doing, but we don't have to explain all of the details if the details are long. And then we move the details to the method here, erase face. So now when you read these steps, then it makes total sense. We say, okay, erase the face, update the location, draw at the new location. So then it makes it easy to understand the code. And how do we erase the face? Well, it's given here. And the advantage of this is now you could, if you do some other animation, you could do that other animation by using this method very easily. For instance, you could imagine that you're going to make the face grow larger by changing the scale. You could imagine that. And how would you do it? You see, let's say you want to add another method, which is void and then change scale. And so you could have, I don't know, a factor for the scale here that you're giving. So you could imagine that now, what would you do? You would say, oh, let's erase the face. You update the scale. So you would multiply the scale possibly by the new factor. And then you redraw. And there you have now a method. You see, it took only a few steps to do it, but you have a method that will do some other animation. And we can see how that goes. Here, if I were to go to funny picture, let's say I do it for this face one. I don't have to write this dot, but I could do this face one and then change scale. And let's say you want to multiply the scale by 1.02 here. So I do this. And then later, I could say, let's change the scale. But I want to bring it back down, so by 1 divided by this. So you could imagine doing that. So now what would happen? Let's see. See, this is moving and growing at the same time. And because of the way we wrote the methods, you see, as each task was in one method, it was very easy then to create a new one. Okay, so that concludes today's session. Any last question for today? You have a problem, Yui? You cannot submit the project. Why is that? I have only 3 minutes here until my next class. You turn it in and so make sure that you turn in your Java classes. Because here, if you have fish.class, maybe you gave me the compile code, but not the Java code. What you turn in should be any class that has an extension .java. So if you have something that says fish.class, please come to my office hour. I'm sure it's something that can be fixed easily. But here I have to end the session because in 2 minutes I'm teaching my next class here. But I'm available at 1:30 for any questions you might have. Okay, so let me end today's session here.